Haley Lamberth, Engineering Project Manager at Phase 4 Engineering. In this video, I will be doing a demonstration of the LEAP Wireless Differential Pressure Transceiver nodes. LEAP Wireless Differential Pressure nodes are often used in conjunction with or to replace mechanical differential pressure gauges, such as this one. Because the LEAP differential pressure sensor is wireless, it installs in minutes. Rather than relying on a person to periodically monitor the mechanical gauge, the LEAP sensor immediately alerts a differential pressure problem that can save time and money. That's why the LEAP industrial differential pressure sensors have a typical ROI of just a few months. The transceiver node has two hose connections at the bottom of the enclosure to take a differential pressure reading. In today's demonstration, we will leave one port open to take the differential pressure reading relative to atmospheric pressure. This is typical when monitoring things like exhaust hoods. LEAP differential pressure sensors can be configured over a wide range of pressure. The wireless differential pressure node comes in a rugged IP68 enclosure with an internal antenna and battery that should last around 5 years. The node also features a bicolor LED that lets you know when the wireless communication status to the gateway has been made. With 3 green blinks, you know you are connected to the gateway and to the software. The transceiver node transmits the pressure data with its unique ID to the gateway. The system uses two-way communication that sends an acknowledgement to the node that the sensor data was received. The gateway can also send configuration and firmware updates to the sensor node. The LEAP Sensor Manager software can be hosted on a gateway, a PC, a local server, a Phase 4 cloud service, or your private cloud. All of the software is web-based, so you can access the software using your password and any web-connected device, such as a PC, smartphone, or tablet. I am going to do a demonstration on this pressure sensor using this Fluke 721 pressure calibrator. I have it reading in H2O at 20 degrees C. I'm going to increase the pressure, and now we can see that our readings in here are reaching up to 7.0, and we'll see here in our device that we're also seeing that same increase in value. When measuring things like turbulent airflow in a duct, the readings can vary significantly due to the turbulence. To dampen the readings and emulate the readings given by a slower reacting mechanical gauge, the averaging dampening coefficient can be adjusted. To do that, I will first click the device, go to Configure Devices, Edit Configuration. The temp weighted average weight, this value here ranges from 0 to 1, where in this instance we have 0.5. If the value is 1.0, this is very raw data. Alternatively, 0.01 is the most extreme averaging that you can apply. Right now, we're right in the middle. You can also look at things like the transmit and sampling interval in that same configuration screen. For the case of this demonstration, I will set the transmit interval to 15 seconds and the sampling interval to 10 seconds. So you can see that these two values are pretty close together. I've only been taking data for the past 10 minutes, so longer duration data, you'll see that those values are a bit closer together. You can go to this Show tabs down here where you can get basic info about your device, the transmit interval, sampling interval. If I want to set an alert for this device, I will select the device, go to Device Alerts, create an alert or notification. I want to apply this alert to all of my differential pressure devices. Now I can say that I want a notification when I have reached a level greater than 4 inches in my water column. And for the sake of this demonstration, I will have an email, a text, and a phone alert sent to Stephen W. when it exceeds that 4-inch water content. Apply the alert. And now, if that value is exceeded, I would see an alert pop up on the top screen, and I'd also have a list of the alerts that were activated because of that threshold exceeding that threshold. Let's do a little demonstration of what that would be like if I did exceed the value. Let me again add some pressure to exceed our threshold limit. For this device, it is a 0 to 4 inch of water, so we have exceeded that limit. It won't read value above that, so we get a notification here on our interface screen showing the alert. We also get to see the list of alerts right here. It was triggered. An email, text, and phone call notification went to Stephen W. If you wanted to download all of the data from this, you would simply click your device. The LEAP product line is designed for flexibility and customization, allowing it to meet all of your specific applications. Other types of sensors, such as temperature sensors, can also be added to the differential pressure transceiver node. Data can easily be exported from the software to another plant software application or PLC using several standard data passing protocols. LEAP sensors take just a few minutes to install and turn painful oh no moments into aha insights on critical equipment and processes. Please don't hesitate to contact an expert at Phase 4 to configure the system to your specific needs.